actually has made my job easier. He has covered quite a bit of talk that I plan to cover in terms of the innovation ecosystem and how we can create the public-private partnership and increase the private sector investment in our country. So we all know what the problem is, that the private sector investment in R&D and innovation is pretty low. But is this, so what really is required to encourage investment? Is the ecosystem ready? And by ecosystem, I mean, is the ecosystem ready to absorb the innovations which are produced by the private sector, and where are these innovations happening really? So let's look at, so Dr. Dar this morning actually covered this bit where, he covered the India versus China. So India is here in terms of the R&D versus the GDP investment, and it has been kind of stagnant for the last decade, and it remains the same percentage versus China. And look at how it has increased, to more than double. And of course, it's the way it's being projected currently. China is going to go more than USA and Japan. So similarly, this is, although we say that the R&D investment by the country has increased, but if you look as a percentage, it hasn't increased much. So this is the Global Innovation Index he was referring to, Dr. Dar. And as you see, this is an old one, and I'll tell you the reason why I'm showing you an older one is because India still features in the top 50 here, but in the current one, it doesn't even feature anywhere in the top 50. So Finland was number one, and when I asked Prabha this morning was that why the educational system needs to actually give more money to the science teachers is because Finland does that. It actually encourages science or creativity to be taught in their the very first couple of years in the schooling, and that is why innovation is a part of their culture. And so, what are the parameters that we're measuring here to measure innovation? These are the enablers. So basically the human resources, the finance to support this innovation. And what are the firm activities? By firm, your firm investment, the R&D investment, but not only that, it also connects the linkages and the entrepreneurship. So basically linkages to the other parts of the ecosystem. And what are the other outputs where the innovators and how it affects the overall economy, right? And so these are the parameters here, and a big part are the intellectual property, and I'll cover why that is important for a firm to invest in innovation. So Finland is top. I think a lot of you guys know that Nokia comes from Finland. It's very strong in ICT. Sweden again, we know the Nobel Prize gets awarded from Sweden. So the dynamite and all these the matchbox. The matchstick was created in Sweden, so I can give you examples. And Switzerland is really top in terms of pharmaceuticals. Japan, we know. Why is Singapore and Israel over here? I think these are really small nations, but almost like the size of our cities here. But they've been very innovative in terms of the government and the private sector being really proactive in terms of supporting the innovation. US, surprisingly, which we all think is innovative, but still ranks less. And of course, India ranks here. China is somewhere, should be at least better than India. So this is the current one. So I think he rightly mentioned, Dr. Dar, that Switzerland is the top country currently, which is the most innovative. And Singapore, which is again a very small country, but still features in the top three. If you see within each continent, in the Northern American continent, USA features, right on the top, while Singapore in Asia is the top one. Similarly, if you see Chile, which is a small country in South America, is called the startup nation as well, like Israel, and it's featuring very, very well. So where is India and China really in all these innovative nations? So it's not doing too bad. And based on these different parameters which are being measured here, we are in these learners, right? So learner, as in, so India and China are doing so this is India. I don't think you can see from very far. This is India and this is China, right? So we are doing very good in terms of learning despite the constraints of the infrastructure. So we are actually not too bad. Switzerland is right on top here. Singapore is here. Sweden's here. So they're right on top, but I think we can catch on by figuring out, what sectors and what things to focus on. So here's the public sector investment in R&D in India. And as you can see, this is the public sector investment in R&D, which is about, so of the 0.8%, a majority is invested in the public sector, while the private sector only invests about 0.616%. Actually, no, I'm wrong. Private sector spending is about 0.12, right? And of the public sector, the majority of this 0.8% is actually invested in defense, right? So so my question here is this a priority for India? Should the agriculture, medicine, and other industries, should that not be a priority? The 20% of the 20% of this, which is 0.16, which is hardly sufficient to, maintain the infrastructure of our country, should we be actually taking out a lot of resources from here to move it to here? And why is, uh, support from the public sector really important to support the private investment as well? Because in agriculture, so this is data from the developing nations in agriculture. So you can see the Asia Pacific, and if you can scroll down all of this, 90% of this investment is done in the public sector in developing countries versus just 50% in industrialized nations. So isn't it important that the public sector institutions actually translate a lot of this R&D into outputs, which is for social good? However, we all know there's a huge value of debt. If you're aware of this terminology, which is basically that the research which is being done in the public sector doesn't really address the private sector needs, which is more applied in nature. So how do we really cross this valley of debt? And so that's why we actually need to create that both public sector and private sector need to set up to the plate to support the R&D and innovation infrastructure in this country. So Barack Obama actually, states very rightly that in order to support the future of US, the factory and workers should be manufacturing the high-tech products, and doing all this needs to be supported by the basic science and engineering, which addresses new products, new businesses, and industries. And thankfully, our Prime Minister also says similar things. He says wise translation of good science and research into products so weak in our country. How do we strengthen the links between universities, research laboratories, and industry? So at least they're on the same page, and let's see what can be done about it. So what are the challenges? The challenges are that, that is there appropriate amount of risk-taking mindset in India? Are the people, more risk-taking? And I think it comes down to, teaching them early on, go ahead and, why don't you jump off this, cliff, or, things like that. So it's okay for them to take that leap of faith. And but are there sufficient resources to, support this risk-taking? And do we have sufficient commercialization capabilities? Do we have an infrastructure to support through intellectual property, respecting intellectual property? Do we have incentives in place for doing all this? I think you can read all this, and it's pretty much, So this is a report that we had covered a few years back, addressing all this and then giving solutions post that. So I'm going back again to the innovation ecosystem that we keep harping about. And so what really is the ecosystem, right? So ecosystem is, the people in it, the institution and the policy which support this ecosystem, and which can actually translate into new ideas, processes, and services, is actually recognized by economists as the innovation ecosystem. And so, put in simple words, so basically it's linkages between the academia, firm, and the government, which is called famously the triple helix in the business world. And we all know that most economically developed nations have very strong ecosystem to support all this. So I can give you a very famous example of how these ecosystems are supported. So we all know Silicon Valley, but do we all know, any of you know here, what's the history of Silicon Valley? You nodding your head. Yeah, can you please explain? I'll go back to the previous slide if you'd like to, because you were part of that, right? So
founded right there. And all of these have the ecosystem of companies that are very innovative, and also they're working with colleges like Stanford and so on. And there's this huge connection between all of them. And in fact, the culture of work was very interesting because when I was given a job offer with Intel, I wanted to know if I get flexible work hours. He said, yes, yes, very flexible. You can come anytime before 8 o'clock and leave anytime after 5 o'clock. I said, that's great, thank you very much. And passionate, they were having another opportunity. They were a little bit more flexible, and I wasn't there. But he came, and I turned out and take on the role of an EDA designer. So I would develop software to design chips. And the whole system worked because they had to keep on working on 50% of the time they would work on production, producing what's there. And then 50% of the time is work on doing research on the next project. And this was a time when life cycle times were like a couple of years. And from there on, it's gone down here, like 6 months and whatnot. And then there was this very interesting times when actually got more and they had to make a decision because Japan was eating them hollow on the memory business. And they weren't sure what to do. And they said, hey, they produced a microprocessor. They said they had to make a decision. And they evaluated. They were so attached to that. But then they said, what would our successor do? Suppose tomorrow somebody else came as CEO and they had to make a decision what to do. Baltimore immediately said he would just drop the memory business. So that's exactly what they did. Said, why should somebody else come and do it? We'll ask us to do it. So can we be so open as to make decisions that we can be more detached to and do? And that is the kind of culture that prevailed. And that's what sustains the organization. And today, HP and IBM and Intel and others are there because they're constantly reinventing themselves. And that's why they're able to still stay in business. There are many other giants that have gone out of business, like Digital and Bank. The bank is not in cloud, but Tech was one. And Sun Microsystems, it's shown a great life, but then this whole saga, but can we constantly reinvent ourselves? And that's the same message we have to ask ourselves here. Can we reinvent ourselves, take what's good, and know what are our strengths, and can we build on those strengths? And then you would be creating the Silicon Valley culture. So,
Thank you. Thank you. That was great. Yeah. You made my job much easier. So, yeah, and I think, new technologies have to keep replacing the old one, otherwise they become, old. So, um, anyway, so this was great perspective, a personal perspective. So, there's a person called William Shockley who actually was recruited from the Bell Labs by Pentagon right around the time when the World War II was going on, and he used to work on the transistors, and subsequently he started working on semiconductors. So after the World War II finished, because he was recruited for actually helping the transmission of data for the spies and things like that, after he got out of the World War II, he actually opened the Shockley Semiconductors, and he recruited the best brains of United States, and of them were Robert Noyce and Gordon Moore, and they were part of this team of 8 who actually left in the Shockley Semiconductors because they couldn't put up with his very dominating personality. And over the years, these traitors 8 actually formed 65 new enterprises, which actually gave rise to the Silicon Valley. And which actually in the economic value created $8 billion at that time, which is like a great impact. And a similar story which comes out of university was, and this is some of the clusters that actually exist, and we have similar clusters, of course, in India as well. The Hyderabad being the pharmaceutical cluster, and Bangalore being the biotech cluster. So similar story which comes out of the university labs was from the UC Berkeley and Stanford University, which we just mentioned. And this was the recombinant DNA technology, which we all have used, and this is now an old technology. So what's the big deal? But at that time, this was back in the 1980s, just around 1975, 80, where these guys were having a beer over a conference, and they said, you know what, we have this cool technology. What do we do with it? And this was the time when this was huge university inventions from Stanford University and UC Berkeley actually changed the entire world in terms of the biotech industry. So um, Herb Boyer actually went on to found Genentech, which is the world's first biotech company. And this was when even the venture capitalism started, trickling in United States. And I'll give you the story later why this was very important for university inventions to get out to the public good. But just to give a little recap, the technology which came out of this was actually worth um, about $80 billion because of the number of companies it created. And there was a huge mismatch in terms of, Herb Boyer wanted an exclusive license for this technology, while Stanford said that no, this is a big platform technology and we will give only non-exclusive licenses. And so that's why it created an entire, ecosystem for supporting the biotech industry post this. So this is an example of how an ecosystem should exist. And I'll keep questioning this. And what I would like is a more interactive session. Please, jump in and you can question me on, why this is an ecosystem and not, the government in the center versus, venture capitalists in the center. So please feel free to stop me at any point and, we can have a discussion over this. So this is a supportive ecosystem that, a modern uh, developing world should, and including our country should be having, where each one of us cross talks to each other, just like me coming from business school talking to you guys, versus a university coming to business school folks and then teaching them something about the science. So this is an example from the evolution of how the Chinese innovation ecosystem evolved. We all think, oh, China, just happened to be, maybe copying and then getting to where it is. But that's not true. Actually, at least 30 years back is when the Chinese government, this is not a very clear slide, but I'll walk you through this. But the Chinese government started systematically investing in science and innovation, right? So they launched a whole bunch of, this is back in the 80s, early 80s, they started launching a whole bunch of programs just to what similarly India is doing right now. They invested in science, invested in the universities, created a whole venture capital industry, or even a government-sponsored venture capitalism, capitalist firms, versus and so versus what it was earlier, because each of these universities, the government firms and public labs work separately. And all the government did was, talk to the public labs. That's it, or maybe to the universities. But firms were left in isolation. And then early 60s, 70s, these three started talking to each other, right? But they were still not part of the ecosystem. And this is when things started changing a little bit, where universities were brought in, and by creating a venture capitalist fund, a government sponsored one, I think they started changing the way innovation was addressed in the country. And this is what it looks right now. So the firms are at the center, because all the inventions which are being created even in the universities are being spun off as firms, and then the rest of the entities are on the periphery, right? So and I think we talked about that NINC, which is the National Innovation Council, actually having this 5,000 crore fund. But I think I'm not sure whether a lot of us are aware that actually. So I've been working with the NINC quite a bit on several of the initiatives, which is more of addressing the bottom of the pyramid needs. And we can talk this offline. But from what I understand, right now they have only 20 crores, and the rest they expect that the private sector would pitch in. So, but what sort of incentives would the private sector have to pitch in this, 4,980 crores? So I think that's a question you and I need to ask. Why is private sector going to be investing in this, or why shouldn't we be actually questioning the public sector output? Is what my question is over here. So let's go back again to the basics, right? So where is all the innovation or R&D being done? So this is a slide from United States, but I think we can apply it to what happens in India as well. So most of the basic research happens in the public sector labs, right? and then you're supposed to show a proof of concept. Then early stage technology development. Then the product needs to be developed, and then obviously you need to have a marketing team around, right? So there's a push versus a pull we were talking about. One of you, the startup that we were talking about, that you created this technology, and now you're going to the public labs or the government to say, why are you not utilizing my technology? And then I think someone also, Dr. Goswami also mentioned that there's a pull factor, right? Or you need to first understand what the market needs are and then work backwards, right? So that is where I think a lot of our scientists are struggling. They're trying to actually create the invention and then push it to the market. I mean, the few which really are trying to push to the market is that here's my technology. This is all I know. I've created this wonderful thing. Can you take this? I've made this pen and I don't know whether you like it, but I still want you to buy it, right? So can we be working backward? And this is what a lot of business schools are being taught right now, is that work backwards. Start first, try to understand your customers' needs. Who is your primary customer? And then start working backwards, right? So who is supporting this? So this is, early stage grants by the government. And then post that are these kind of investors, the angel investors, the venture capitalists, and then, the PE funds and things like that. So, as I said, the first value of death we all know, that is the mismatch between the basic science and applied science. The second mismatch happens, or the second value of death happens when you don't have any funds, right? So, as a scientist, I think, oh, I have created this great thing. Here's my basic science. I think I, have applied it. The government is supporting this, but then as soon as the government support runs out, who's supposed to put in all that money? I don't have any money to put this, into my venture, but this is a great venture. So you have your friends, family, and fools put in money into it, which is what this category is, and they're also called angel investors. In some, nice person who actually happens to be a friend with a lot of money, so they put in money. But then, if you don't get any money, so your invention dies. It never sees the light of the day. And so, can you bridge this by ensuring that your technology has the market and then trying to pitch your ideas to the potential investors? So, here's another slide where, this is the how your invention can go down if you don't have this, funding mechanism to fall in place with your, advancement in your technology development. So, why am I bringing all this, right? So, and what really changed this entire thing, which I talked about, the whole commercialization of public science to, address private needs, was that this did not happen in the United States overnight, right? It's not like the United States or some of the scientists in US woke up and said, you know what, I'm going to start applying it back to, or giving it back to society. There were certain acts or certain bills in United States which were pushed forward, which enabled university inventions to actually reach to the public. And so before 1980, there were only 5% of the university inventions reaching the public or making any commercial good. So this 5% actually changed. And remember when I said the Genentech technology, the recombinant DNA technology, that was the first university invention, and that it was enabled by the Bayh-Dole Act. The Bayh-Dole Act actually what it does is that so these two folks, the Bay and the Dole, these were their last names. These were the senators of United States, just like we have the members of parliament here. And I wish we have similar act, which I'll talk about in India. So maybe you can call the Sybil and the Raju Act, or whoever the current ministers are, name it after them. So what they did was they actually gave the ownership, transferred the ownership of this intellectual property to from the funding agency. So if I'm funding, so if I am DST, I'm funding it. So instead of DST owning it, they actually gave it to the respective universities, that they are the owners, and then they give incentives in terms of royalties or monetary awards to when you get royalty out of commercializing your science. So you actually get royalties, and those that incentivizes the scientists to commercialize their science. And so we have an equivalent bill still pending in the parliament for the last I believe 5 years or more. It's called the Protection and Utilization of Publicly Funded Intellectual Property Right. And it is similar to this, but apparently, and I think, they are in this current provision of the Science and Technology Implementation rule book that we have. there is very strict march-in rights. And by march-in rights, I mean, if I am making this invention and this is for the good of for the country, it's an emergency. I'm going to march in and just take your IP and make it available to the rest of the public. So my question comes in. I mean, the question comes in that there is compulsory licensing happening for those of you probably reading about the pharmaceutical industry and all. Um, that's a separate story in itself. But if I and we all know not much inventions are happening in India. So if I were to invest quite a bit of money, which is like at least let's say 20 crores, and sufficient bit of time, would the government come in tomorrow and say that this is required for the country? I'm going to take it away from you. So should I be investing in this technology at all? So I think the provision for the merchant rights need to be toned down in this current policy. So why is university commercialization important, and is it important to the country? So if you just take one particular year, so let's say this is a 2008, I believe. So 2008, the university inventions created an economic impact in United States of billion dollars. Sorry. So this is a huge, huge amount. I don't even know. I mean, I'm not an economics person, but some of economists over here can probably tell me. I think this should probably be the entire GDP of a certain nation, right? So that is the power of university invention, and are we creating that kind of power over here in India? And so majority of these startups which are happening, so let's say this was there were 555 startups in this particular year 2007, and 402 were primarily in the state where they formed. So let's say Andhra Pradesh is actually creating let's say 100 startups, and 800 of them sorry 80 of them were in Andhra Pradesh, and they were creating a huge economic impact for Andhra Pradesh in terms of creating jobs and then revenue for the state and infrastructure needs. Let's skip this slide. So let's see what are the models of cooperation, right? So it's just not that the scientist just goes out there and then creates a venture. He doesn't have the need, the means to do it. So what if I don't know how to do this A plus Z, A to Z? So let's like just do the ABC and then transfer it to the next, like a relay race. So here they can do specialty research, and which is supported by external grants, or then they can actually transfer the technology to firms and get royalties based on that. So oftentimes in universities, this is what is happening, right? And then a few scientists, a few daring scientists actually would take a sabbatical and then go out and start their own ventures because they don't want to leave the because they're not very risk taking in terms of going and starting the venture, right? So I think we should have means and ways so that scientists can actually take sabbaticals to go and start the venture, as opposed to saying that there's a very strict time frame of only 2 years, which then where venture can actually support itself and be functional in 2 years. It's not possible. So let's say that it'll be a longer time frame, and then you would get your tenure even based on commercial applications versus just publication based tenure track, which is not even happening, right? So are we saying that our scientists are being promoted based on their publications? I don't think so. So I think when we talk about let's create this many universities, I think we should be talking about should we be producing quality versus quantity. Quantity can be done through vocational schools and other hands-on training programs versus just mass producing these graduates with no skills at all. So these are again different forms of commercialization happening. So either they can license it to an existing firm, the scientist can have a startup, and if he thinks that I can't take this forward, then still license it out, right? And there are these commercially sponsored research, and by commercially sponsored, I don't mean by like just doing the consulting form, which the current professors are famous for doing. I think there should be a more hands-on approach where I am going to make these technologies, which is if I am interested in doing application-based science, let's do that and start a firm. So and this involves a lot of inputs from the industry. So why is intellectual property really important, right? So Steve Jobs didn't invent design, but he ensured that he patented it, right? So he didn't create the iPod, and I mean he actually utilized the existing products and just made it more appealing to the market. So when you need to go through this technological product cycle in order to address the market, versus when we had this Walkman and the entire industry didn't really take on to it. He made products which were more appealing to the society, and but he ensured that he gets money for this, right? And that's what is the incentive, and I think that's where I keep going back, that our scientists needs to be incentivized. And similarly, even for the industry, we need to provide them incentives in order to say that let's do this, let's not tango just without providing you incentive. I can't force things on you. So especially for pharmaceutical industry, because that's what I've been working on. But I think this actually goes on for a lot of other industries as well, because unless until you have something to protect your invention, and by that I meant, I think earlier too I have said that, unless until I can protect the investment of time and money, how am I going to actually invest anything at all, right? Why will I create something breakthrough if I cannot protect it and get return in terms of monetary returns to do it. And so here's an example which I actually am familiar with, but a lot of you as well, is that it takes about 802 million or at least $1 billion with a, let's say, a firm called NERC. And in absence of patent protection, what would happen? If you were the pharmaceutical firm NERC, and I would say, oh wow, very nice, you've created this invention. Fine. I actually would like to copy this. Can we do that? And you would be very angry, right? You would say that no way. So I would just go ahead and copy it, and that reduces your incentive to invest in R&D. And so, in order to do, in order to actually make this effective, you have to enhance. You have to actually incentivize the firms to actually invest in innovation and R&D, and by that you can actually protect your intellectual rights. And so these are and then we all know that that we all have been saying the big pharmaceutical pipeline has been running dry. It takes at least 10 years to create this, and no big one big pharmaceutical industry has been able to take out a drug in the last couple of years. I think it was just Merck's Januvia, which is anti-diabetic drug, which came out of its pipeline. All it does, it's a lot of these big pharmas, and then they actually engage with universities, small biotech firms, in order to replenish their pipeline, because they know that they can't do the entire value chain by themselves. So collaboration is the way forward, right? And then so by private sector investment, you can actually collaborate with universities, which are the breeding grounds for innovation. And let's say that you can't take this forward, but let me come and collaborate with you. So I'm going to jump this slide, and so let's see what's happening in India. So we actually had this legacy, the great legacy that we say, that we actually learned English from them, and they actually made us miss the industrial revolution. So what happened really was that, being a more so we jumped the primary sector, which was more agriculture and mining driven, to more secondary sector, which is services based sector, right? So we never really entered the industrial revolution, which is more the manufacturing, and which is where China did better. They've invested a lot in manufacturing, and while we missed that train. So, but we did sufficiently well in the pharmaceuticals, because the government's focus was that let's actually invest in process innovation, and that helped us to learn from copying, and that's fine too. A lot of the innovation literature says that it's fine to copy until you know how to learn by doing yourself, right? So, which is there's a famous case study from Korea. Is that earlier, I think, if someone were to say 20 years back, will you buy a Korean car, and everyone would scoof at you, or like, so even Samsung, right? No one would buy that. But now they're the top of the line innovators in terms of phones, in terms of automobile, excuse me, automobiles. So so I think we've learned enough by copying or by doing. So let's now become innovators. Let's now do some breakthrough innovations of our own. So what are we leaders in, right? So we've done very well in agriculture. We are the top three on number three, and in software, which is the service sector, which I call it. It's number two. So I think we have a lot to provide in all these different sectors, considering that we have Vinod Khoslas of the world, and a lot of the startups in United States are founded by Indian entrepreneurs. So I think we can actually play on these sectors, and contribute and be in the top five in the next decade or two. So have we done very well in publications? I think when we say basic science, let's see how much we've published, and this is the benchmark, the uh, the gold standard for publications, right? So let's just say, for me, it's Nature publications. How have we done? So China is here, and a decade back, which is let's see, China is here, the red one. A decade back, China and India were similar, right? So this is 2000, and look where they went, right? And look at India, which is this color, the purple color. We have been the top from the bottom. Great, right? So I don't think we've done very well in basic research as well. So where are we really lacking? Should we be questioning our scientists that, is your quality really good? So I think there are several things that we need to change in the way the science and technology, policies are being implemented in India. So can we align some of the incentives? And here's an example from IIT Bombay. So they actually, back in 2000, so this is in 2000, they didn't have any technology transfer or any licensing happening, right? So and then in 2005 and 6, some great person decided that, you know what, let's incentivize our scientists. And let's say that we'll give 70% of the licensing fee to the inventor. All of a sudden, so from here to just 5 years, right? So from zero licensing fee in 2000, it jumped to quite a bit, right? So just by incentivizing the scientists, I've all of a sudden changed the mindset. Instead of saying that you get your salary, yes, you get your salary, but I'm giving you this bonus that let's make these applications which addresses things, or it will help you as well. You'll get a lot of money out of it. So all of a sudden, you have actually provided incentive for these scientists. And quite recently, this is one great thing which happened in the recent union budget, is that the union budget has proposed, Chidambaram, he proposed that the incubators set up by companies at academic institutions can qualify as the corporate social responsibility, which there's a 2% mandatory corporate social responsibility. Oftentimes they say we'll donate to a hospital or we'll, support this government run schools, but we all know where that is, right? So can we actually really create these incubators or the technology transfer offices which can support the innovation and R&D ecosystem? Right. So you can do a lot of things with the right. Right. So a lot of things can actually, I think they need to be start. They need to be questioned as to where this is being utilized, right? And I think if you can actually put the onus on the corporates themselves, right, and then let's do really some social good, not just for namesake. I think a lot of us should start feeling proud of the country rather than just saying that I'm a citizen of the country, right? So right, 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 right. Yeah, yeah, yeah. Yeah, yeah. So my daughter every day she gets frustrated. She sees anything and she's like, made in China, made in China. So it's like, so I said you can make it made in India or made in anything except, and there's nothing wrong in China doing that. They've done it and they've shown it, right? So we need to show it as well. So I think when people start comparing India and China, I don't think that's a good analogy, because I think we need to be questioning that have we done sufficient bit? I don't think there's any comparison. Those guys are way ahead. If you go to China, you'll see that they're decades ahead, right? So it's good to be compared, but I don't think we're anywhere near. So there's a long, long way to go. So these are the three pillars which I think are very important. And here are some recommendations. I think we can talk this offline. I'm going to skip this slide, but this is a very important slide, because these are the three pillars which really support the ecosystem. The intellectual property. We've moved from the process patent to the product patent, but I think we're still not there yet. And especially in the last year or so, I think a lot of things have actually really shown that I don't think we're really respecting this. So in terms of MNC's patent being respected or the Indian patent, I think it's going to come somewhere down the line. So then the talent, we all know things have been covered. And I think funding is the big part, especially in life science sector. This huge amount of funding needs to be put in because there's huge risk. I think we have an innovator, Biram, you were from IKP. So he knows that it's very difficult to get money for, his venture. And any of the pharmaceutical friends who work in the pharma industry, they know that even though they're the most brilliant scientists out there, but to set up their farm, they need to start working on generics versus, their drug discovery, because not single funding agency would support that system for 10 years, right? Because they need the returns right away. And also, I think we need to have some looser bankruptcy law. And I think we talked about that this morning also. I think you briefly mentioned it. How do we support these startups, the high risk startups, without actually having let's say that, it's okay to fail, right? But it's not okay to fail. I think in India, we actually have this big uh, a taboo against failure, right? Oh, this person's venture failed. Oh my God. Versus in the West, it's a badge of honor that, yes, I'm a serial entrepreneur. All my ventures fail, but I've learned from that, right? I've learned, and my fifth one is going to be really good. So I think we need to have a looser bankruptcy law, but at the same time, stringent enough to see that, there are checks and balances where you ensure that people don't misutilize it. And I think this is very important. We have really missed out on innovation is by actually not having the the foreign direct investment, because at least in the software industry, yes, Microsoft and all these people have invested in India, and actually we've gained quite a bit out of that. But can we name, other than, let's say, in agriculture, Monsanto, which other big agriculture firm or the chemical based firm have invested? DuPont. But in pharmaceutical, I don't think I can say any. If we say Novartis has a center here, that's a back end office. That's not a R&D center. And I think AstraZeneca is the only drug pharmaceutical firm which is doing research only in TB and nothing else, right? So there's no other big pharmaceutical firm which has invested in India. But let's say that, okay, fine, the generic firms have thrived, but I think we could have learned a lot of from the R&D. Scientists like me didn't have to go to US to learn some of that R&D. Had we had these MNCs set up shop right here, right? So I don't think we've learned innovation in terms of, like, let's say, taking from the chemical synthesis to the next stage, from copycat to being more innovator-driven firms. And then we need to tap into our Indian diaspora. These guys are pretty rich. How can we ask them to actually start investing? And by that, I think, Indians are pretty smart, but at the same time, when the government tries to engage with them, they actually see through a lot of things, right? They say they're pretty. They ask, you know, where are you going to utilize this money? Because knowing the experience, I don't think they're going to, do justice by just giving it away like a charity. So I think that philanthropy also needs to be brought in, but we need to actually start seeing, where the money goes. So, I'm going to cite some successful examples. Feel free to, please tell your examples if you think, there's some very good successful examples which need to be highlighted in terms of both, I keep talking the PPP models, but also in terms of how private sector have invested. So, um, and I think you referred to this a little bit, the semiconductor industry. And I'm trying to give perspective from a lot of different industries because I don't want to be skewed towards one particular industry. Because I think we don't have these multidisciplinary schools in India. I think you talked about the hospitals and the medical school being together. But we need to have like the hospital, medical school, the agricultural school, the engineering school, the business school all together. We don't have any of those world-class universities in India. And I think a lot of these innovations actually get died because there's no crosstalk between the different schools. So we need to set up schools which actually have these multidisciplinary schools, not just the sciences, but also medicine and engineering and things like that. So this was a famous example where often a national crisis gives rise to a whole new technology or industry. So in back in 1980s, the Japanese were the leaders in semiconductor. And then US thought, oh my God, how are we going to compete against the Japanese? And that was the point when the Japanese were the leaders in all sorts of technologies, the cars, and you name it. So they said, okay, the government incentivized the US industry. Until then, they had this skeptic eye towards each other. So the US industry, 14 of them came together, and they were given a fund of $500 million by the government. This was in the 80s. So you can imagine how much that was worth. That was worth quite a bit. And by 1990s, actually, they were having more than half the world chips were being manufactured by this consortia. So this was a consortia, and like Dr. Vani said, that consortia he was referring to this morning, consortia can work in a very nice way if the incentives are aligned for them, and things fall in place. And there are a lot of problems as well. Like someone asked him, if decide where to leave in the consortia, would it still function? So a lot of things, incentives, and how things work in consortia need to be thought through. But this is one example where people can take away in forming, taking the private sector investment in R&D. This is another private sector price for life. So, we have all heard of maybe X prizes, where you say, I'm going to launch this rocket into the spaceship and offer you $1 million. Similar $1 million was offered to solve this problem, the Lou Gehrig disease. And one of the university scientists actually cracked this problem by designing a tool to track the progression, which is very important when you have such a disease. And some similar one was later designed for Alzheimer's disease. And for maybe those of you who've had, anyone who has Alzheimer's, it's very important that you track the disease in time so that you can contain it. And so, and then you incentivize with, prizes in terms of monetary reward, and of course, rewards in other ways. So it depends on like how. So suppose you're working in a public sector institution, right? So I think you probably have laws set by the government that you're going to undertake only research which is sponsored by the government, and what if you're doing for this, right? So I'm not very clear on those things, but the next example that I'm giving you, actually a lot of the prize money went to Indian researchers. So that is something I think you can ask the government as to, if I'm actually going to put in sufficient bit of time into this, half my time into creating this. So I think they should be, you should be allowed to do it. And in my opinion, yes, you should be allowed to do it because you're actually addressing a market need, and you're also getting, you can actually put it in your resume that I've solved a direct need of a person, and I think that should be okay. But I'm not sure. I don't know whether we don't have any DST folks here to clarify. Mhm, mhm, mhm. So I think the DIPP has come up with these pricing regulations. I think they've come at least in the, but I don't think, that depends on you. You decide what the, initial investment of time and money was, and you also time in your, the time you've put in, right? You don't come free. You obviously, have self-paid your family because, you've left them, but that's money also. Your time also is money. So you can factor in, and I think a lot of times that comes under valuation that you call business valuation or your product valuation. But then what's the end user willing to pay for it? In the end, I can value it whatever, but I think the venture capitalists know and they laugh at it. It's like they say, oh, you know what, you can value it like $1 billion, but I know this is worth only 100 million. There are no takers. This is what I value it as. But I think a lot of times when they do these valuations, they take into picture how many people you have customers, what's your customer base, how much are they willing to pay. So there are a lot of factors which I'll can address later offline. Yeah. So this is another model where so this was launched by by Eli Lilly. It's a big pharmaceutical firm um, called Innocentive, right? So these guys couldn't solve everything in house, and this is what the problem is. A lot of times, often people don't like to admit it, but that's true. I'm not a jack of all trades, so that's fine. I can go and approach a person who really knows the best, or actually I can crowdsource. It's called crowdsourcing. So I can post my problem in public domain, and then any one of you can actually, it's a website. So in fact, after this talk, you can go to this website, Innocentive, and then you can actually look at the problems that are being posed. So initially, they started posing their in-house problems, and then they started having firms who wanted their problems to be solved by crowdsourcing ideas or through open innovation platform, and in return they get prizes, right? So in fact, a lot of folks, so the prizes range from, the amount ranges from $500 to, excuse me, $50,000. And a lot of Indians actually have been winning these prizes. And this could be some bioinformatics problem, some protein folding. And you would think, oh, I don't know about it. But the truth of the matter is there are a lot of folks who actually won these prizes were from multidisciplinary areas like mathematicians, So just for the fun of it, they actually have been going and playing these games, and they've won prizes. In fact, the yeah, please. Wow. Uh-huh. So, and the latest idea is that crowdfunding, right? So there are sites where you can actually say that this is my firm, this is my profile, and instead of going to angel investors or venture capitalists, people have been actually getting crowdfunding. So I actually don't know venture capitalists, so but there are platforms where you can go pose your idea. This is what I want to take forward, and if folks like it, they will actually invest in your. And this could be from $1, right? I like your idea. I have only $1 to give you, but I'll give you $1, and someone might give, but then it adds on, and then you can actually get quite a bit for your seed money for your venture. So later on, yeah, so sponsoring firms started putting in their, and so this is quite successful. And the sponsoring firms can remain anonymous, and at the same time, if the solution comes through, and if there's an IP involved, oftentimes they actually share the IP with the person who's won the prize. So there are other instances. In fact, there are a lot of money to be made in these kind of ventures, at least these two. So these are these groups, right? They are these the trolls. They call them technology trolls, similar to that, but they have a bad word around it. But I think these are these IP groups. This is a firm called IP Group. So they've had tie-ups with. This is a UK-based group. They screen IP from universities and spin it out. So let's say that I'm not able to go find people who are willing to take this firm. So, but I have let's say we are very famous for contract research organizations. So can a person actually form such an organization and say that I'm going to look through each of these universities and help them spin out companies, or at least find potential licensors for their technology. So these guys have actually been very successful with just, and of course UK is pretty good in life sciences. So they've spun out 63 companies from just 10 universities, and that's a big deal. If we know, I think we've been saying that, oh, Shanta Biotech came out of CCMB, but but let's say, can we have more Shanta Biotechs or more Bharat Biotechs which come out of universities, as opposed to people going to US doing the postdoc and then coming up and then coming back and trying to struggle to put their venture together. This is another venture called Biopontus. It's a US based firm, and these guys have networked with 8 academic partners where they exclusively license these technologies, but then subsequently they work on it. So let's say BRAM actually takes up a license from the university and then works on it, so that then it becomes attractive enough for these firms to take it forward, right? So these people also are like middle people where they would take technologies, but this is their work. They, instead of trying to get, so let's say Advinus, one of the pharmaceutical firms, is a contract research organization, but what they do is they take projects from them and work on it and then give it back, right? So can they instead start working with some of the academic partners and say that we will develop your technology and then try to license it out to potential firms? And this is, I think, Eli Lilly has been pretty proactive in terms of launching ventures, the crowdsourcing, and then also launching a mirror fund, right? I think those of you probably know that Eli Lilly also had problems, but they've been doing all sorts of other ways to make money. So they invested in a venture fund, just like any other venture fund would work, called the Mirror Venture Fund. So what they said, that initially we are going to put in half the experimental drugs for companies to work at, and then get more money from other ventures, right? So they raised sufficient money from other funds to take this forward, and so that it's called something called corporate ventures, where I will support a biotech firm because I can't do everything in house. So these are the new ways of supporting innovation, and this happens a lot in the IT sector. So let's say Microsoft actually does their venture fund, and I believe now Merck also has their own venture fund. So I think we can do, let's say Reddy Labs does it. So I think there's lots of risk taking which needs to be encouraged in India. And so these are some other models. This is more private sector driven, or the NGOs which are driving these, right? So, but it can also be the governments driving it. So can we start levying taxes on airlines? This was a new method to actually to fund HIV, malaria, and tuberculosis. And the way they levied these taxes was every airline ticket bought in Europe was used, some bit of the taxes was utilized for this fund. This was a great way. I think we should be doing some of this. And this is where I worked at, my alma mater at Kentucky, University of Kentucky. And I worked on tobacco. That was my research for my graduate school. And the way this was funded was that every packet of cigarette which was sold in Kentucky, 5 cents of that went to researching, my research. So this was another great way of doing it. So you actually can start taxing liquor, and let's say that let's fund something on alcoholism or things like that, right? And this is another great organization called Medicines Patent Pool, and this is where innovator firm would actually submit their patents, and any generic firm can go and get their patents in exchange for like a licensing fee. So they pay about 5% licensing fee to this organization, which would actually then in turn pay to the innovator firm. But then everyone can get access to this patent, which normally would have actually gone for 20 years, right? But then now I can tap into this patent much earlier than. So I'll give some example later, so this was another UCSF, got a deal with Genentech. And actually, if you remember from my previous slides, Genentech came out of UCSF, right? So they gave a $13 million grant to it to support researchers, and I think we can do a lot of that if we start showing that our universities can do really good research. And I think when I've talked to a lot of scientists, I talk to academic scientists, but the minute I say commercialization, right? So although their technology, they probably don't even have anything yet, but the minute you say that you can get some money, they immediately want to know how much am I going to get, instead of saying that what can I produce. I think a lot of the scientists also need to be educated on, that normally your research would have been just lying on the shelf. Can you be actually making this more, otherwise would you be actually doing anything worthwhile? Maybe publication, yes, you'll get to your next, next promotion. But otherwise, they're okay with, their technology lying on the shelf. But the minute you say, anything about industry, and so there's a lot of this trust factor which needs to be coming in from the academic partner as well. Because I talked to the firm side, and they say that, we want to actually have these partnerships, right? They want to have these partnerships, but the academic partner, they starts demanding a lot more. So there has to be a middle ground that, the trust factor needs to be built between academia and the private sector in order to take this forward, because no one can do everything on their own, and we know how much the private sector is actually doing in terms of research, which is not much. So this is a great initiative which UCSF started called the QB3 Garage, and the reason it's called Garage because Silicon Valley is obsessed with garage. Everything has to be garage because they did their startup in the garage. So they call it QB3 Garage, and it was so successful. Well, it's not really a garage; it's a fancy building, really. So so now they have 3 other garages, these QB3 Garage, where initially they started off with these industry-sponsored alliances. And by the way, UCSF is not just a University of California at San Francisco in Vic Manthrai Disciplinary School. It's actually just a medical center, but the best medical center, I think, in terms of commercialization. So then they started doing, making proof of concept. And then they said, what, actually our technologies are pretty good. We are going to actually put a startup in a box, which is like, have a manual which tells, what really requires, you to make a startup. We'll put that manual together, help you do it. So, they will make you operational and get you funding as well, right? So I'll show you what it really looks like. This is what it really looks like. This used to be like the bad part of the town. And Arnold Schwarzenegger was, the then governor of this California. And he said, what, we can actually make UCSF, this is downtown, this was the bad part of the town. I don't know whether you're aware which part of the town this is, but so he actually created a very good incentive for a lot of these firms to establish over there. So he created an ecosystem right there. So he created an ecosystem for the firms, the medical center. The medical center doesn't mean just medical science, medical school students, but also the scientists who work in medical school, and also the venture capitalists to be the venture cap groups to be right over there, and then even lawyers. So what happens is that, there are these guys, doing research, but they're at the same time talking to the firms because their graduates actually leave here and join here. So there are lots of these connections, spillover effect, sorry. And then, where do they get the finance from? These are, a lot of ex-scientists actually move on from here in their career path to become venture capitalists. And, you need lawyers to start a firm. So a lot of them do pro bono work with these guys, saying that, okay, fine, I'm going to work for free with you in the hope that, once your firm is established, you're going to come back with your corporate affairs later, and, I'm going to start charging you money post that. So that's the kind of ecosystem I'm talking about. And so now these guys have formed 64 firms, created $226 million, attracted $226 million in financing, just this one university. And, this number is small, but we know, how nimble biotechs are. They're pretty nimble despite the small number of jobs, but they've created quite a bit of impact. So these are some stories. I'm going to skip this. So this is one story that I've been working with. I've been working with this Gilead group who actually licensed out a technology from Emory University, where they actually, so HIV drugs, I think this particular population is actually a little bit on the older side. Normally I give this talk to students where I have to tell them back in the 90s they used to take like 20 pills a day, the HIV patients, but we all now know that it has come down from 20 pills to now just a pill a day, right? And it used to cost tens of thousands of dollars to actually get this much amount. So it was a deadly disease. And so the technology that they got, Gilead, this group, Gilead is a life science firm in California-based firm, and these guys got this technology out from Emory and made it possible to just make it a pill a day. And this is where I'm giving you an actual story where this has changed lives of people. So what they did was, the way they realized back in 2006 that the majority of patients that they're actually covering is outside of United States. So they built this health access program, which covered barely only 200 patients across the world. And they said, we're not reaching the real patients, right? And of course, real patients, and also the money may not be much, but then we need to be addressing the needs of the entire world because this is a great drug. So how can we reach this entire world? We have a patent around it. What do we do? And they were just a California-based firm or United States-based firm. They had a bit of operations in Europe. So how do they reach the entire world? So they, said that let's license it to these Indian manufacturers who are really great in copying, very good in manufacturing these mass manufacturing drugs. So let's give out these licenses in terms of, so this is called voluntary licensing, right? So I will voluntarily give my license in return for a royalty of 5%, which is low, but it's fine. As long as I'm able to reach the majority of the world. And because all these guys work in Africa, sub-Saharan Africa and Thailand and everywhere, so they will help them. So Gilead will help them get the FDA approval, but they need to have their own, the firms need to have their own distribution network, right? So there was price wars, the price of the drugs went down. So from just 200 patients, in 2006, so so it was much less here, actually so in 2006, their patient population was 31,000 from 200 back much earlier. So now they've covered 1.6 million patients. The price of the drug from, if you remember in 1990s, it used to be tens of thousands. It has come down to $6.15 a month. This is, and they also have tiered pricing, right? So they need to break even in their, good markets, which is US, and the rest of the world, the rest of them. But because of the volumes, right? Because of the mass population that they are able to cover, and despite the thin margins, they've made quite a bit of money. It's a win-win situation for the innovator firm and other firms who actually require this technology. And so these are different models where it's not just public-private partnership, but also partnerships with the within the private sector also has brought innovation to all sorts of world. And I think I want to make a comment where can we also incentivize? So we see a lot of these north-south partnerships, right? So partnerships between European companies or Indian companies, with Indian companies, but not within the Indian companies. Do we see these partnerships within the Indian companies to take these forward? So I'll quickly go over some of the initiatives that we're doing at ISB to create these ecosystem and to create such partnerships with ICRSAT and some of the other private and public sector units. So here's program that we are running, which is going to be a technology commercialization program. It's a 4-day executive education program which trains professionals like you who probably have technologies which you want to take it to the market but don't know how to do it. So this would train you in product development, intellectual property, so all the various A to Z, which really takes it to the market. So these are the other, and we're going to have a person who's a veteran venture capitalist at Burrell. He is going to teach this program. He is also a faculty at Wharton Healthcare. So he's going to tell you what it really requires. And you may think that he's based in US. How does he know about India? But he's been working with the emerging economy firms, especially Indian firms as well. So you will get a lot of hands-on, training from him if you'd like to learn A to Z. And there's other things that we're trying to do is, how do we help some of, so like I said, if you have a technology, but you need to find a potential licensing firm, you can't take it all the way yourself. So we've also set up a technology showcasing and a boot camp, right? So this would actually help you find potential licensors, investors, so not just licensing, investing also option, and also showcase your technology to get input from the mentors, right? So, and it will actually have pre-boot camp workshops for all the things. So this would be a one-up on the previous slide that I talked about, and opportunity assessment, feasibility analysis, and the last one, which is the most exciting, and I'm really passionate about, is actually we want to create an acceleration program. And I think most of you probably don't know what an acceleration program is. So usually incubators are like, I would teach my child to, start crawling. But an acceleration program is where I would actually teach the child to start running, right? So we would take already existing ventures, life science ventures, which would actually have the potential to make a social impact, but have still financial stability and the potential for growth, and actually accelerate them. So we would actually put a whole team of both scientific and business mentors to help these firms really go to the next level. And so, and this would actually cover a whole bunch of life science ventures, including agriculture. And so this would be so we are trying to foster the next big firm. So we are initially trying to just encourage a couple of ventures, just 2 or 3 to begin with. And I just thought I'll put it out there. So what ISB is trying to do for the ecosystem. And so, over all these training, we want to catch some big ventures, and then really, mentor them to take it to the next level and become like the Genentechs of the world and change